Welcome viewers. In this video we'll see the implementation of combinational logic using demultiplexer. Example 1, full subtractor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Implementation of combinational logic using demultiplexer. Here we are going to implement the full subtractor using the demultiplexer. So in the first step, we need to write the truth table of the full subtractor. Then we need to represent the full subtractor in the min term form, because in multiplexer we get the min term as a output. Right. Now we'll see the truth table of the full subtractor. So the full subtractor, the two terms available, a and b. Input is a and b, and borrow from the previous digit. This is borrow in, b in. So totally 3 inputs, A, B, borrow in. Right. Then the output is difference between this and borrow out. What is borrow out for next digit? So A, B, borrow in is 3 inputs. Difference and borrow out is the 2 outputs. So because of 3, A, B, B in 3 combination, 2 to the power 3, there are 8 combinations are available. 0, 0, 0, 0, 0, 1 up to 1, 1, 1. Right. Suppose A 0, B 0 and borrow 0. All are 0 means difference is 0 and borrow out also 0. 0, 0, 1. Right. What happens? 0 minus 0 is 0. 0 minus 1. What happens? 0 minus 1. Here the 0 is there. 1. We need to subtract 0 from 1. Subtract. What happened? This is more number. This is lesser number. We need to borrow from previous digit. While borrow it become 10. 10 means 2 in decimal. So 2 minus 1 is 1. So the difference is 1 and borrow also 1. We borrow 1 from previous digit and difference also 1. So 0 minus 1 means we cannot subtract. So we need to borrow from previous digit. While borrow 1 from previous digit, 1 0 become 10. 10 means 2. 2 minus 1, 1. So the difference is 1 and borrow also 1. Right. So 0 minus 1 means difference is 1 and borrow also 1. Here is same thing, 0 minus 1. So next third one is 0 already, so no problem. So 0 minus 1 means 1, 1. Difference is 1 and borrow also 1. Here 0 minus 1 means difference is 1 and borrow is 1, but here one more 1 is there. So this 1 minus 1 become 0. Only borrow is 1. 1 minus 0 and 1 minus 0, nothing will happen. The difference is 1, borrow is 0. Here 1 minus 0, again 1 minus 1. 1 minus 1 means difference also 0, borrow also 0. Here also 1 minus 1. Difference is 0, borrow is 0. Here 1 minus 1. Both are 0. But 0 minus 1 become 1, 1. 0 minus 1 means difference 1, borrow 1. Right. So now we completed the truth table. Right. So A, B, borrow in 3 inputs, difference, borrow 2 outputs. Now this is represented, this 0, 0, 0, 0, 0, 1 is represented in min term, M0, M1, M2, M3, M4, M5, M6, and M7. So this is represented in min terms. This corresponding 0, 0, 0, 0, 0, 1, 0, 1, 0. Right. So the difference we have here 1 is available. 1, 2, 3, 4 ones are available. That is corresponding M1, M2, M4 and M7. These 4 are available as high level. So that is the required terms for generating the difference. That is sum of min term 1, 2, 4, 7. This is 1, 2, 4, 7. Right. So difference equal to the logical expression in terms of min terms is given as sum of min term 1, 2, 4, 7. In case of borrow out, again this is 1, 2, 3 and 7. So 1, 2, 3, 7 is available for borrow out. Right. 1, 2, 4, 7 we need a required output for difference. 1, 2, 3, 7 is the required output for borrow out. Right. Now we have the truth table. From that we got the logical expression for difference and borrow in terms of min terms. Right. In terms of min terms. Right. Now we need to go for the demultiplexer. We need to implement with the demultiplexer. We know that demultiplexer is one input 2 to the power n output and n selection lines. This one output is converted into 2 to the power n outputs by using the selection line. The selection line will decide 2 to the power n outputs. That is the demultiplexer logic. One input, 2 to the power n outputs and n selection lines. Here the three variables available, a, b, borrow in. So a, b, c or a, b, borrow in. So 1 is to 2 to the power 3 we need. That is 1 is to 8 multiplexer is needed. In that what we have? We need 3 selection lines. We need 3 selection lines, right? So we need 1 is to 8 multiplexer. That means there are 3 selection lines will be available. What is these 3 selection lines? 3 selection line is nothing but ABC. That is AB borrow in, right? What is the one input? One input is 1. The input is the data in is the, will give 1 as a input. So that we'll got 8 different outputs. The input is given as 1. The selection line is given as A, B and borrow in. We'll get 8 different output. In that we need only 1, 2, 4, 7 for difference. 1, 2, 3, 7 for borrow out, right? All 8 outputs will be available. In that we need to connect 1, 2, 4, 7 for difference, 1, 2, 3, 7 for borrow out, right? What is this? Sum of min term. Sum. This is sum. So we need to add. So we need one OR gate here. 1, 2, 4, 7s are connected in OR gate, so that we'll get sum of min term. Here also we need one more OR gate. Now we'll see the logical diagram for implementing full subtractor using the demultiplexer, right? So this is the 1 is to 8 demux. 1 input and 8 outputs are available. This is the selection line. A, B, C or A, B borrow in, right? So 0, 0, 0 means we'll get Y0 as a output. 0, 0, 1 means Y1 as a output. Other things are 0. 0, 1, 0 means Y2. 0, 1, 1 means Y3. Similarly, 1, 0, 0 means Y4. 1, 0, 1 means Y5. 1, 1, 0 means Y6. 1, 1, 1 means Y7. According to the input, we'll get. So that is available in our truth table also, right? So these 8 outputs will be available, but we need for a difference, what we need is 1, 2, 4, 7, right? So this 1 is connected, 2 is connected, and 4 is connected, and 7 is connected, right? 1, 2, 4, 7. These 4 inputs are connected. We are not connected, why not? Why not is not required. So this is OR gate. So sum of min terms. These 3, 4 terms are added together. We'll get the difference. So here we'll get the difference of the full subtractor. Similarly for bar out, what we need? 1, 2, 3, 7. Right? So this 1 is connected. Here 2 is connected. Then 3 is connected. Then 7 is connected. Right? So 1, 2, 3, 7. So here we got the, this is the sum of min terms. So OR gate we are used. We got the borrow out. Right? So we implemented the full subtractor using demultiplexer. Data in is 1. Selection line is nothing but 3 inputs. A, B, borrow in. The 8 different outputs available. Based on the truth table, difference mean we need the sum of min term 1, 2, 4, 7. This 1, 2, 4, 7 is connected together. For borrow out, what we need? 1, 2, 3, 7. So 1, 2, 3, 7 connected, we got the borrow out. So in this video, we discuss how to implement the full subtractor using the demultiplexer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.